When you think about what makes you uniquely human, some things might come to mind. The fact that we're incredibly social, the fact that we can kind of simulate the future and the past. But one thing that's really fascinating is our capacity for creating and appreciating music. This seems to be something that really sets us apart from other animals. Our ability to kind of move with the beat, to predict beat, to have this music evoke emotion, to bring out kind of every emotion across the entire spectrum: anger, sadness, and happiness, all of these things, right? It can bring back distant memories. You have people with Alzheimer's that can't remember anything until they listen to some music, and then all of a sudden they can tell you this whole life story. And it has these healing qualities to it as well. It seems to be so entwined in all of our cognitive processes, and it really makes you think what kind of led to the evolution of our kind of capacity to kind of work with and understand music. So this is all stuff that we're going to get into today, and it's a really fascinating topic. So I hope you kind of stick with us.
Welcome to the Social Brain. I'm Andrew.
And I'm Taylor. And this is a show where we dive into how the brain works. If you've ever wondered what's going on inside your mind, even the things that you're not even aware of, then this is the place where we can unpack that and really explore it.
Yeah, and it's strange to just contemplate the fact that like music, unlike anything else, and most other things that we listen to, look at, it doesn't really convey any explicit information unless you're talking about lyrics. But we can have music without lyrics, and like indeed that's some of the most emotionally moving and evocative music that we listen to. And it's odd to kind of think of this thing that seems so normal. We hear music all of the time, right? Like you're in a grocery store, you're driving in your car, maybe you're working and you're listening to music at the same time. And yet it's just in reality meaningless patterns of tones of sounds that are coming into your ears and then made meaningful by your brain. And that's kind of what we want to talk about today. These various ways that the brain processes, understands, and then makes music emotionally meaningful.
I really like how you put that too, because like think about it from another animal's perspective. Like if you were to all of a sudden be a dog and you're in the room while like human you is like jamming out and grooving to some music, is it just noise to that dog? Is it just a bunch of sounds that aren't being made into something meaningful, right? We seem to, as humans, have this incredible capacity to sync our entire kind of perception to this beat, to this groove. It ties itself into the way that we're laying down memories of that moment, the way that we're moving through our space, the way we're timing the things that we're doing, right? It's so tied up with all of what we do. And it seems to be, we're going to kind of get into the origins of this, but it seems to be really heavily tied to our capacity for language as well. Because there's a lot of people that originally thought, music is something that's innate to animals because we all have rhythm, right? We have heartbeats, we have gait, we have all of these things that we do that have some rhythmic quality. Brainwaves themselves have certain rhythms to them, right? And so shouldn't it be the case that all animals kind of have the capacity for understanding and appreciating like rhythmic qualities? And it might not be the case.
Yeah, and it really ties in with our last episode on timing because we'll get in a little bit more to rhythm later. But I mean, in the last episode, one of the things we mentioned was that there are these really, the brain doesn't have one central master clock. It's like there are intrinsic properties of neurons and populations of neurons that allow for timing to occur in the brain. So like our ability to time on the range of milliseconds to seconds. And we have all these different mechanisms for different time scales. And it seems like we'll get into this, but it seems like music is tapping into this very innate property of timing in the brain. And we'll talk about some of how it's perhaps doing that and how the motor system is involved. But as we've really alluded to here, there's this this question of how did music evolve, or what does it serve some kind of evolutionary purpose? Was it an adaptation, or a byproduct, an exaptation in evolution? And yeah, I guess the first idea around that was the guy who's credited with coming up with evolution by natural selection, which is Charles Darwin. And he thought that music may have evolved before language, because he saw this tight similarity between the two, the use sort of communication, and that it may have been involved in sexual selection. But yeah, I think so. We'll get into that a little bit more here.
Because the origins of music are really important, because we need to know what sets us apart from other animals. Like, why is it that we ended up kind of surrounding ourselves with this kind of synchronous type sound, right? Because when we talk, it's not synchronous. We take turns talking, right? We're communicating information back and forth. But music has this quality of us all doing the same thing at the same time, listening to the same thing, and training to this thing, right? Something that Andrew just hinted at, kind of these links to our past episode on time, is that our brain is constantly in training, which means that it's getting in sync with things that are happening in the outside world, right? We're getting in sync with daylight cycles so that we can know when to wake up and know when to go to sleep and all of these kind of things. And there's all kinds of different things at different time scales, and somehow we as humans have just like latched on to this music thing. And there's actually a lot of debate. So Darwin was really big. He had a huge section like in his book about evolution, about music, and believed that it was something that was like part of this evolutionary pressure. There's a lot of people, though, that are kind of on the other side of that don't think that it was like part of the evolution, that it was more of just kind of a cultural creation, and has nothing to do with genes or any of that. And it really, there's no way to know like whether music or language came first, but there's a lot of kind of evidence from some of like the apes that so like chimpanzees will do this thing called panhooting, where they'll all kind of hoot in sync with each other. That doesn't have any type of communicative value to it. It's not signaling something specific. It's more of just like this synchronized sound between all of the chimpanzees. And we even think like there's a lot of people that think that like Neanderthals kind of used music as a form of language. It's kind of one of the ways I heard it put was like Charlie Brown, right? So Charlie Brown, you have those characters that are just like they weren't saying words, but they're communicating emotion, right? You can when they're angry, right? You can tell when they're sad, right? That there's something about kind of this prosody of the way that music, that pitch, that tone, and all of that kind of stuff is able to communicate some of these emotions in a way that may have been kind of prototypically language centered.
Yeah, and it's interesting to reflect on the various ways that we can make music, or different sort of aspects of music, like using our chest or hands clapping as like a drum or a sort of a percussion instrument, and then of course our voices, right, singing and everything. But I was just thinking about whistling, and whistling seems to be like we use it for communicating across like long distances, and then communicating even with like other animals, with dogs and horses and stuff like that. And I don't know, that thought just came to mind. I haven't heard much talk or writing about whistling in the literature that we've reviewed before this episode, but yeah, it just came to mind as a very simple form of sort of musical communication.
And let's put some of this into perspective, right? Because when we think about music, we are talking about something really ancient in terms of what we've discovered as like from anthropology and all of these things. The earliest instrument that we found was a bone flute that is 40,000 years old. And like when I throw that number out, that number might not, like, it sounds really old, but like let's put things into perspective, right? Because 40,000 years ago was when the woolly mammoths were going extinct. Right. It's when Neanderthals and Homo sapiens were living at the same time. Right. And we found evidence of a flute. Right. A flute means that we have gone to the point of creating music with an external object. Right. So music was probably even a lot older than that, from kind of vocal intonations, from like Andrew was saying, using like rhythm with drums and things. Right. There's a lot of people that think that there's some sort of kind of evolutionary benefit to synchronization, which is a huge part of music, right? Think about people in their canoes, like traveling from like one island to another. There's a lot of need to be in sync when you're rowing together, right? Having some drum that keeps the beat, right? That keeps things kind of in sync so that you can predict when the next thing needs to happen. There's even like theories about when we're all singing in sync and we're all kind of together, that it makes our group look stronger when we're like up against another group, right? There's a lot of benefit, they think, from kind of having these kind of abilities to synchronize with one another through sound.
Yeah, yeah, it's like when a lot of human beings get together in a group, and especially when they're sort of rallying around like a common cause or something, like at a concert or at a sports game or something, it's very common to see just, spontaneous synchronization of movement and singing as well. But I mean, there, like Taylor mentioned, there are some people that just think that this is, a fortunate but insignificant, basically, byproduct of our language or our sound processing more generally, or auditory processing more generally. And then like some pretty, significant figures like William James, who was kind of a contemporary of Darwin a little bit later, but the sort of the father of American experimental psychology, wrote like the first big textbook in American psychology, and he said something like, music has no zoological utility, and similarly later on, Steven Pinker, the who's a very preeminent psychologist and a cognitive scientist and author, and he's written that music is auditory cheesecake, that we could get rid of music and everything about our lives would stay basically the same. And it's just an interesting quirk of evolution. But a lot of people, especially those who study, the neuroscience of music, the psychology of music, and others in this sort of field, they disagree with that interpretation for some of the reasons that we've just been explaining. But I think it's important to mention that there are differing perspectives on this. And in my opinion, I could see it either way. But to me, it seems pretty compelling, the idea of, I can't remember who this theorist researcher was, but they had this idea of the musa language, that it wasn't that music evolved first and then came language, or the other way around. It was that they sort of evolved as a hybrid. And it was this that allowed us to communicate more effectively and precisely than like our animal ancestors.
And I think what this really leads to is this really kind of interesting kind of, I don't know if it's like meeting in the middle with these two ideas, but there's some researchers that are like, it doesn't really matter whether music or language came first. What is probably going on is some type of gene culture interaction, that there's a feedback loop, because we're at the point now as humans where it does seem like there's something genetic that is linked to our appreciation of music. There are people that have amusia, which is like an inability to appreciate or kind of understand why people appreciate music. And they've seen genetic markers that are linked to this. They've seen differences in kind of brain kind of structure, volume, in terms of things being connected to each other. And you look at how innate this is now, right? Like I have a 4-year-old. You can look up like videos on the internet of babies that you put on some music and they're grooving to it, right? Like my kid has been dancing since he was like a year old, right? That there is something that we come into this world with the ability already to kind of appreciate rhythm and stuff, right? There was this one, like, oh, I wish that we could like put it on right now, but there was this really cool study that they did where they were trying to understand kind of this innate ability that, and if you start playing Stevie Wonder's Superstition, it starts with just kind of this kind of beat, this rhythm, and they had people just kind of tapping their fingers to the beat. That was the only instruction, just tap your fingers to the beat. But then all of a sudden, the like groove guitar guitar comes on, very superstitious. And all of these people in the study just spontaneously started moving other vectors, which meant they were moving their head and their neck and their shoulders and their arms, right? There's something about just the grooviness, and it's rated as like one of the grooviest songs of all time, but there's something about that just automatically captures something inside of us. And one of the main ideas of this kind of culture gene coevolution is linked to other similar things, right? So we as humans, we as culturally kind of started to cook our food. We started to spend time together around fire and cooked our food. And because of that, we didn't need to have as long of a GI tract to extract nutrients. We didn't need jaws that were as strong as they were to really chew through raw food and all of these things. That cultural invention of cooking food then led to an entire kind of change in our genetic makeup that changed us into different kind of biological entities. And they think that something similar is probably happening with music, that whether it was before language or after language, whatever, music being a part of our culture has started to change the way that our brain has evolved.
Yeah, that's such a good point, and it makes sense for sure. And I was just going to mention when you're talking about amusia, because this is something
Yeah.
I had never heard of before starting to learn about this years ago. But it just sounds like for most of us who appreciate music, the vast majority of us, whatever kind of music you like, you can recognize even music that you don't like as being music, as being structured, or even music you've never heard before. It's, like maybe music from India or from some other continent that you've never been to, let alone, heard music from. And then, but there are people who it doesn't sound like that. And that's the strangest thing I think about perception in general, but with music, it seems so odd because, so Oliver Sacks, who wrote this book called Musicophilia,
Great.
and he's a neurologist, or he was a neurologist. He passed away about 10 years ago, but he wrote about a patient that he had who had amusia, and she said it sounded like he asked, what does music sound like to you when you listen to it? And she said, it sounds like if you went in the kitchen and took all the pots and pans and threw them on the floor. That's what music sounds like to me. And it just, so it's important to recognize that, none of us are, some of us are trained, right, in music explicitly. We might learn to be musicians or even just learn music appreciation or something like that. But nobody, or not nobody, but most people don't have to actually go through training to appreciate music to some degree. Just like Taylor's saying, babies will like bop their head to music. If music is played, while the fetus, right, is still developing, later on they tend to recognize that music more than music that wasn't played around them in the kind of prenatal environment. But yeah, no, it's important to recognize like there are actual genetic, hardwired aspects of music, and some of these come down to even really ancient brain structures, like phylogenetically ancient brain structures, like the brainstem, and that music can have an effect on these really early auditory processing areas that then give us kind of an emotional experience due to that music. But sort of moved a little bit off topic there.
No, it's all good. I mean, one of the things that really struck me that Oliver Sacks said about music, that music is a stimulus, something that comes from the outside world, right? That has the ability to activate more of the brain than almost any other stimulus that we've seen, because it's so intimately connected with all of these different cognitive processes, like Andrew was just saying. It hits stuff in the brainstem, it hits stuff in these kind of subcortical emotional areas. It's tied into all of these memory centers. It messes with our attention and brings us into some kind of focus, right? It tied into all of these, and something we're going to talk about later. It's also tied into our identity. It's like in this part of the brain that's involved in like self-concept. It's like that's the part that pops up all the time in these music studies that they do, right? So it's something that is so pervasive across the brain, and it really kind of begs the question then, like how is it that that we got here, right? And like one of the things that I think is really fascinating are the studies on what's called beat perception synchronization. So our ability as humans to synchronize to the beat, to actually predict when the beat is going to happen, right? So if you start a metronome and you tell someone to kind of tap their finger to the beat of that metronome, that humans will usually tap right on the beat or just before the beat, right? Which is indication that we're actually kind of predicting when the next one's going to happen. We understand this rhythmic quality, and we understand, okay, that means that another one's coming right now, right? Other animals can't do that. And they're like, they can be trained to a certain extent, but even when they're trained, it's reactionary. It's either on the beat or right after, not before. And so there seems to be something about the way that, and they think a lot of it is language, the way that we're predicting what someone is going to say next, right? That there's this really tight coupling between kind of these action motor regions and these auditory regions that are giving us the ability to kind of predict this rhythmic quality to something.
Yeah, and I mean, even chimpanzees can't do that synchronizing to even a metronome. Like Taylor said, it can be right after, sort of like it's like they're hearing it and then their reaction to it. But we naturally start to predict it, and there are correlates in the brain, like electrical activity, that are like correlated with the this kind of synchronization. And I won't bore you with the names of them, but basically they are signatures that can be seen on an EEG, on an electroencephalogram, basically looking at the electrical activity sort of emanating from the brain. And you can see that there are these really discrete, really recognizable signatures of when we are hearing a beat, for example, and then say it misses a beat, right? You'll be able to see this signature in the EEG when that happens. And if we're really surprised by that, that signature will be a higher amplitude. So there are these neural correlates of this ability of this predictive processing of music. And so that's kind of one of the big areas of studying music in the brain, is looking at this prediction like Taylor's talking about.
Something, so there's this researcher Ani Patel that is fascinating. I love listening to this guy talk. He's one of the main people behind some of the research into this kind of beat perception idea, and a lot of the work that he was doing was kind of pointing to the idea that humans are kind of unique in our ability to do this and to keep kind of rhythm and tracking and everything. And they ended up getting a video of this bird that someone has. It's a cockatoo that was able to kind of dance to the rhythm of music. There's no one in the like behind the camera that's dancing, that they're like imitating or anything like that. And they went and they researched this bird, and they tried to understand, like, okay, what's going on. And it seemed to be that this bird was kind of keeping, and one of the things that's really important in terms of these beat perception ideas is that one thing that humans are really good at is that if the tempo speeds up or if the tempo slows down, we can adjust to that really easily. We can start tapping quicker and we can start tapping slower. Other animals, like the ones that we were talking about that can be trained to this, have a really hard time with that when tempo speeds up. But this bird, as the tempo speeds up and slows down, it can just keep the rhythm and it starts moving. And they thought at first, maybe these are just kind of gestures that are linked to, like head bobs are kind of bonding and mating kind of things. But then they looked and it had this whole repertoire of dance moves like humans do, like lifting their feet up and like doing this like mohawk thing and all of these, and being able to change the beat. And so it really led to this idea that the ability to synchronize to the beat, to understand and predict the beat, is actually really common in animals that have to learn vocally, have to learn to imitate sound, right? So that's something that songbirds do, that parrots are really good at, right? Of hearing a sound and then recreating it. And what we're doing when we're recreating a sound is we're creating a link between the sense of hearing something and then the sense of recreating that sound. And now we're creating this pathway between sense perception and motor action, which creates this predictive feedback loop that they think is tied into our ability to kind of predict the beat.
Yeah, and we see in those studies, they see a lot of activation of well, in the neuroimaging studies, you see
Mhm.
activation of motor related areas of the brain, like the supplementary motor area. These are like in the premotor cortex areas that are kind of on the sort of top of the cortex, but then also these subcortical regions that are involved in movement, and like the areas like the cerebellum and the basal ganglia, kind of deep in the brain. And so music, it's important, I guess, to realize that music is not just auditory, especially music with like a heavy beat, rhythm element to it, is also motor. It's a motor experience too. And it's real, like Taylor's mentioned, it's really hard to not try to keep time with music, especially when it's like very rhythm heavy.
And I think it's something that's really important to mention in those studies that you were just talking about, Andrew. They were seeing this activity in these premotor areas, in kind of subcortical motor areas, when the subject was not moving. And so it's not even that they have to be like grooving to the beat. These motor areas of the brain are keeping track of that rhythm, even if you're not externally moving any body part. So it's showing that the brain is incredibly entrained to the timing of whatever you're listening to, which is a really important kind of step in towards like understanding, okay, now that we've connected these two regions of kind of our ability to listen and hear these sounds, our ability to kind of recreate them, we're starting to see now that's how it maybe got its way into everything else. Because something we've talked a lot about on this show is that the brain's primary objective is to move. Like that's probably why brains evolved in the first place, was so that you could go from here to there to go get food, right? And so that means that movement is tied in with so much stuff, with attention, with memory, with predictive coding, and knowing where things are so we know where to move, all of that, right? So as soon as music gets this like this way in, now it's able to just connect itself to all of these other different cognitive processes that are going on.
In addition to just moving us around, right? I think that the brain's other primary, or maybe even sort of tied into it as like a hybrid primary job, is to help us figure out what's out there in the world, to better understand our environment so that we can move around. So it's like it's in the service of moving, but it also kind of we slowly figure out using this predictive processing to understand like what is in our environment visually, what can we explore and exploit. And so it seems like music, by tapping into both kind of perception and action, seems to have this kind of like deep effect on our brain in some way. And I mean, I think throughout this conversation, it's important to just think about your own experience of music and some of the most like emotionally moving songs that you've ever heard, and how they seem to give you an emotional response, but also some of like the groovier ones, the ones that when you're actually wanting to move to the music. That's actually what, I'll stop at groove. That's what groove actually means. I don't know if we've noted this yet, but in the literature, groove is like a measure of how much people report wanting to move to the music.
Mm-hmm.
So some songs are super groovy or have a high degree of groove, and others are lower. But yeah, there's something that like wants to get our bodies involved about music.
And I think that really ties into some of these emotional qualities, right? Finding out what's out there really is this idea of kind of approach and avoidance, like what's really beneficial, what's not beneficial, right? And somehow it seems like music has tied its way into the capacity for us to kind of remember what's good and what's not, and in kind of a more complex spectrum, what made us angry, what made us sad, what made us happy, right? It's able to really kind of encapsulate a lot of those memories and hold them to something that allows us to recreate that entire kind of feeling and emotion, right? When people are sad, there's this paradoxical thing that they want to listen to sad music, right? And it's because it kind of encapsulates and allows them to really kind of put the whole package of that emotion together with other experiences and other memories and other things that are tied to that kind of quality that the music brings with it. And so I think that's really something evolutionarily that's kind of interesting to think about in terms of how it's tied to everything.
Yeah, and I feel like it's so tied in with the sort of social nature of music. And we are an ultra social species. This podcast is called The Social Brain. We've talked a lot about the significance of social processing in the brain, but music has this like deeply social element. We tend to make music with others. We tend to experience music with others, but and specifically with sad songs, like you're mentioning. The liking of the song can be separated from
Hmm.
the like emotional valence, like Taylor's saying. I mean, typically you don't seek out experiences that'll make you sad, but with music it seems to have this kind of cathartic effect. Like
Yeah.
if I listen to a really sad song, one that always gets me, I'm not quite sure why, but the Sound of Silence, especially the rendition by Disturbed, which is it's a beautiful song, but
Yeah.
it has a really sad quality to it and kind of dark. And for me, it's like, it's a sort of catharsis, and it almost feels like I'm sharing that emotional experience with someone else, with the
Yeah.
singer or the band itself. And it makes you feel sort of this almost like communal aspect of like getting through that emotion together. I think that's super interesting. And it ties into these, like Taylor's saying, these emotion networks in the brain, or these regions
Yeah.
that are important for various aspects of emotion, like sort of the pleasure networks, especially areas like the nucleus accumbens, which is part of the ventral striatum, kind of deep in the brain. This shows, so when people like music more, as you would expect, this region lights up more. And that's really common for all kinds of pleasures, whether you're winning money or eating some sugary food or something like that. You get this activation of this region. But there's also an interesting thing where people who lack like this amusia, are
Hmm.
basically people who don't get any pleasure out of listening to music, show decreased connectivity between the auditory cortex and the ventral striatum.
Yeah.
And but they can still experience pleasure in response to other things. So it's like this connection between these auditory regions and these sort of more emotional regions have something to do with, have a great deal to do with our experience of like enjoying music.
And it makes sense putting things together like this. I mean, that's the dopamine system is down here, nucleus accumbens, ventral tegmental area. Dopamine is really important in predictive coding, in terms of it like lights up when something surprising happens, right, that we weren't predicting, that's then tied to laying down memories about that thing, right? So all of these connections start to kind of paint this picture of how it's kind of tied into all of these systems. I really loved what you're talking about with like the social side of it though too, because there's an artist that I came across recently within the last year, NF.
Oh
He's
yeah.
he's a rap artist, but he doesn't like doesn't curse at all in his music, and he sings specifically about like mental health. And like I've been through a lot of traumatic stuff, and like listening to a lot of his music is powerful. It really moves me in a way, because it does kind of universalize and generalize these things that I've felt, and it puts them into perspective. It kind of ties in these emotional qualities to it, right? uh, there's something really important, I think, that we've been trying to kind of get home, that they've started to kind of tease apart with what Andrew was talking about with these kind of connectivity analyses, looking at they use what's called diffusion tensor imaging, where they're looking at the white matter tracks between these different areas. And one of the big ones that sets humans apart is kind of this track from the auditory region to the motor region. The other one that Andrew was just talking about is the auditory region to all of these subcortical regions that are involved in reward processing and emotion processing and all of these things that we see in these people that report an inability to experience rhythm, an inability to appreciate music, these kind of different connectivity patterns in these people, which hints also at something genetic as well, that there might be something that's kind of worked its way into our genome that allows for these connections that give music the kind of quality that it does with us.
Yeah, and kind of explain the individual differences somewhat between us. I mean, I don't think that's all genetic. Just like
Mm-hmm.
basically nothing about us is all genetic, but it can go a long way to explain like why some people just have perfect pitch, or just
Yeah.
are have a knack for playing music. I mean, like I look at my brother and I. My brother is a really great musician. I mean, he's learned several instruments, and he can teach himself, and he's very skilled. He's got a lot of different things that kind of go along with music perception and production that make him like, I don't think he's just naturally good. He's done a lot of practice too, but I mean, I never, I didn't have like, first of all, the interest that he did. And I also didn't, put in the time and the hours that he did to get to that level. But I think there's something there, like some individual differences between our brains. I will say something that probably nobody knows about on this podcast. I don't even think Taylor knows this, but I can do a very low level, novice level of freestyle rapping. And I've done that since I was a teenager, which sounds funny to say, but it's something that just like, as over time, as I practiced it, it became like more and more natural. And I'm not saying like I'm a great freestyle rapper, but it's interesting how, I don't know, you might have like a natural predisposition towards certain kinds of music. And it's not, rap isn't even like my favorite kind of music. So it's interesting that that's what happened for me.
Stay tuned for the Patreon only episode. We are going to see some rapping from Andrew. I think this leads in really well to this other idea, which is really kind of central to some of my interests in music because of what I study. So I personally study self-referential processing, which is a kind of fancy way of saying I try to understand how information that's related to who we are, our self-concept, things that are important to us, like you were just saying, Andrew, with your brother, like these things became something that were part of his passion, part of what he kind of centered his world around. How do these types of information kind of affect the way that the brain processes that information? And there's a part of the brain that pops up really, really reliably whenever you think about yourself in any way. And that's the ventral medial prefrontal cortex. It's kind of above your eyes here in the middle of your brain. And it pops up for if you're thinking about traits that describe you, if you're thinking about things that you like, if you're thinking about things that you own versus things that you don't own, right? And something that really stood out to me in a lot of the research that we've done for this episode is that the region that pops up super reliably across all of these music studies is the ventral medial prefrontal cortex. And it pops up really robustly when people report liking the song, when people self-select the song. So it's something that like it's like part of them, right? That it starts to show that this music is in some ways tied into our self-concept, right? And I think something that's really interesting, if we go back to our adolescent episode, didn't get a ton of views, but it's like one of my favorite ones that we've done, if you want to check that one out. But something that's really, really unique about adolescence is it's when we're forming that self-concept, right? When we're really trying to understand who we are, how we fit in, right? And if you reflect on your life right now and you think about those pieces of music, those songs that really stand out, I bet you that a large majority of them were songs that you liked in your adolescence.
Or at least they're the same genre, right? That's another thing. I've heard, like, yeah, it might be slightly different, but no, it is wild how long that sticks around. And just like you're saying, in our adolescence episode, we talk about there's all these ways of seeing that the brain is especially plastic during adolescence, like laying down memories like crazy and learning about the world, especially the social world and oneself. And so it's kind of no surprise when you look at it from that angle that the music that we fall in love with as teenagers and adolescents sticks with us for kind of the rest of our life. But just like everything, there's some degree of course, like adult plasticity. It's not like you can never learn to like anything else, but maybe there'll be an especially powerful emotional impact of that music that, you know, really was hitting you in those sort of angsty teen years.
But I think it shows how powerful music can be in terms of kind of memory, in terms of these things that are really, that hit really close to home, right? That like a lot of these songs that we listen to they have themes, they have kind of the lyrics are in some way tied to like experiences that we're going through, things that are important to us, right? Emotions that are really important to us, right? All of these things that are really tied into our need space. Like that's really how I like to understand the self, is that it's this collection of needs, right? We have physiological needs, we have to eat and drink and all of those kind of things, but we as humans are incredibly social, and so many of our needs are tied up in our relationships with other people, and in whether people like us or don't like us, in how we're comparing to other people. And like music is this really interesting way of connecting so many of these dots, of getting into a group, right? Belonging to a group because we all like the same music, right? I remember just like hating Yellow Card just because my friends did, even though like I knew all the words to to some of the songs, right? But and then as I grew up, I was just like, wow, the only reason I hated it was because I was trying to like be in the ska group, right? Like, and it's so tied into I think the idea of how it affects our memory, right? Because I think that our identity is kind of the core aspects of our memory. It's what ties so many pieces of who we are together across years, across decades, right? And something that we'll kind of lean into now, kind of the memory aspects of memory of music are so powerful because they're able to reignite old lost memories, and they can, like, you listen to a song and all of a
Yeah.
sudden like you're back in that truck, like driving on that dirt road with all your friends, right? Really interesting stuff.
Definitely. And I mean, like Alzheimer's disease, right, is famously or infamously this disease that affects memory, especially, and our sense of who we are and identity. And, one of the correlates of Alzheimer's is the buildup of these plaques, especially in areas like the hippocampus and the prefrontal cortex, these areas that are very important for memory, self-control, self understanding, really, and like our sense of self. And so, that the right people start to lose kind of themselves, and it can be really hard to watch. But a kind of fascinating thing about dementia and Alzheimer's is that music can sometimes, like Taylor's saying, reawaken some of these memories. And sometimes it's just procedural. Like, again, going back to Oliver Sacks, he talks about this patient that he had that had like pretty severe dementia, and he didn't remember who he was. He didn't remember what he had done for a living for his entire life. He couldn't remember what he had for breakfast yesterday. But when he went to go play music, it was like 80 or 90 years old. And when he went to go play with the band that he played with, he did a perfect performance, and he could do that every time. Mm-hmm. And it's kind of partly because there are these different memory systems, right? There are these explicit memories where like the hippocampus is very much involved in our memories of people and places and events and things. But then we also have kind of a motor memory, or a procedural memory system. And that seems to be maybe more intact in Alzheimer's, and then can be sort of tapped into with music. And I will note, he also talked about how this guy didn't know what a tennis racket was, but could go play tennis and play perfectly well. So it's just showing that dissociation of the different memory systems.
And I think this is a really kind of important point to kind of hammer home, is that these different memory systems, there's like kind of this traditional view of thinking about memory as just like there's this long-term memory over here, and there's this thing that you access it with or whatever. Memory and perception are intimately linked. We have a whole episode that we did about this. That's really fascinating. That like what memory actually is this massive web of associations that we've linked things together, right? What I like to think of when I think about the hippocampus, right? The hippocampus is something that gets really heavily damaged really early on with Alzheimer's, is that it's kind of like the Google search bar, right? It's what's able to, you're like, okay, my 21st birthday, right? And then all of a sudden it's like, okay, 21st birthday, let's activate that chain of associations, right? And it serves as the starting point for igniting what's not in the hippocampus, because the memories are all through the cortex. They're what we lived, right? It's reigniting all of those things that were active when we actually did that thing, when we saw those things on our 21st birthday, the music we listened to, all of those things. But when that Google search bar is gone, what's really interesting about music is that the music can bypass it, because all of a sudden now you're in this beat, you're in this rhythm, this melody, and those have associations already connected with them in the cortex, right? So now all of a sudden, all of those things that were connected to that music, without having to have a search bar or something to search with, all of a sudden, all of that stuff is getting turned on. All of those memories are getting reignited, right? Uh, there's a fascinating documentary that you should check out. It's on Prime Video, I think, but it's called Alive Inside, and it's about these Alzheimer's and dementia wards, where this guy is just going around with iPods and headphones and trying to get some sense from family, from people, like what their favorite music was. And there's this really interesting example. They go in and they're talking to this guy Henry, and he's just like really non-responsive. Like, tell me about your life. Oh, I can't remember. Couldn't even recognize who his own daughter was, right? Couldn't tell him anything about their lives. He loved gospel music, and they put some gospel music on. All of a sudden, this person just lights up. I mean, this has gotten like millions and millions of views, just that one clip. Starts singing to the music. And then all of a sudden, they take his headphones off, and he spends 10-15 minutes telling this whole story about his life, about when he was in the Navy, and like his kids and all of this stuff, right? All of a sudden, all of these memories are reignited. Name me one medication that can do that, right? It can't, because these things, they're so entwined with who we are, with what we feel, our sense of loss, our sense of love, that is all tangled in these webs of associations throughout our brain. We have billions and billions of neurons that have thousands of connections. All right, we're in like the trillions area now, and if you can get the right beat, the right rhythm, the right melody, you can ignite those things. You can bring people back to life in terms of memory, in terms of enjoyment. Really cool.
It is fascinating, and it reminds me. It gives me a memory of this. Sorry, but as we're talking about music as therapy, another interesting finding that has to do with kids with severe autism who are nonverbal, who have never spoken, learned to speak, or just not been able to kind of express that capacity. And they might make noises and sounds and things like that, but there are some studies where like clinical trials with music, where they use music to help train these kids to be able to speak. And it's really fascinating. I mean, it's like intensive training for weeks on end, but it's basically like they use like a simple phrase, like what's that, what is that, or something like that, but they repeatedly kind of train these kids to sing that. And for some reason, it may have to do with the two halves of the brain kind of processing and having different aspects, different functions in the production of speech and music, where they are able to sing that phrase slowly over time, and then able to speak it, able to say it. And I'm not fully clear on exactly like the mechanisms behind that, and I don't know if all the researchers are yet either, but there is some evidence from elsewhere that like people with damage to the left kind of frontal lobe, the Broca's area, this area that's involved in producing speech, can't naturally just speak anymore. But when they use some similar kind of music training, they're able to sing what they want to say. And that's a really fascinating thing about music too, that it seems to, again, come back to this idea of this musa-language, or this intertwining of music and language in evolution, or perhaps just in our development. But it's fascinating, the different uses for music in therapy.
And that ties into something that's really interesting about kind of the lateral components, like left brain, right brain idea. So left brain is supposed to be language, right? It's the production of language, understanding language, all of these things. You get a lot more left activity with this stuff. But what they've found is that the right half of the brain is actually really in tune to prosody, which means that it's really in tune to kind of the pitch and then the inflection of what you're saying. So if I'm saying something really angrily, the right half of the brain is really tuned into how you're saying that, right? The tone that you're saying that. And so that really ties into what Andrew was just saying. This musa-language kind of thing is the two halves of the brain kind of working together. The right half bringing in kind of the prosody, the pitch, the tone, everything that's happening, and then the left half bringing in kind of the meaning of a lot of these words and putting them together. Something that I've come across, like with my wife. I don't know if you've kind of come across this at all, but I tend, when I listen to music, to really focus on the rhythm and the melody, and my spouse spends a lot of time listening to the actual lyrics, right? And there are times where I'll listen to a whole song where I have no idea what the song is about. Like I feel it, like there's an emotional quality to it, but there might be some kind of interesting like individual different stuff there with like how people interact with it, and whether they're focusing more on the words or focusing more on kind of the feeling of it, and that could be tied to whether we're processing it on one side of the brain or not.
Yeah, that's really funny. I think I do definitely latch on to lyrics a lot more. I like really focus on what's happening with the lyrics, but I don't know if this is completely related. This may just be a tangent, but when it comes to just language, I find like I pick up on accents. Like I'll notice someone has an accent more so than my fiance or sometimes other people. Like a while back, you and I, Taylor, we were listening to a researcher, Paul Chiswick, who I was like, oh, sometimes his accent, it's kind of a little bit hard to understand certain words that he says. And you're like, he doesn't have an accent. We had this disagreement until we figured out he's from
Right.
Poland and stuff, but may have something to do with that difference between the different kind of modules in the brain that are processing, just the words themselves or the prosody. But that's one kind of separation and in the brain of these systems that is interesting. And there's another one that I had just recently come across where, so maybe I'll just read this quote. It's kind of a long quote and it's a little bit technical, but it might help to just like get this idea out, and then we can explain it. This comes from a paper by Wust and colleagues, and that's the first author, and it was published, I think, 2022 in Nature Neuroscience. But anyway, they write that the auditory cortices are central to pitch processing, where fMRI suggests that pitch height is processed in a region posterior to the auditory A1 cortex. I'm kind of adding to this here, but the part I wanted to get to is that in general, the recognition of pitch from spectrally complex sounds is thought to be handled by a ventral stream, projecting from primary auditory areas along middle and anterior regions to the inferior frontal gyrus. A dorsal stream projecting from primary areas via the I'm just going to move through this. A dorsal stream is supposed to support sensory motor integration, articulation, and memory functions. And the reason I mention that is that is a very common kind of general architecture that we see in the brain, that especially for perception, for whether it's language perception, whether it's just vision or auditory processing more broadly, you see this ventral dorsal separation. And there's always some overlap, and it's not super clean, but ventral meaning kind of closer to the bottom of the brain, dorsal meaning closer to sort of the top. And so anyway, I just want to mention that they're talking about how pitch, the recognition of pitch seems to be more carried along this ventral stream. And then the kind of memory, sensory motor integration, these sort of maybe higher level, if we want to think of it that way, parts of music are carried through this dorsal stream. So sorry, that was a lot of jargon there, but I think hopefully that's clear.
No, I think it's integral to how we live our lives, right? That we need to both understand what something is and what to do about it, right? And that's, I mean, when you look at, you were talking about kind of general perceptual processing, these ventral dorsal streams, that's what a lot of it is, right? When I see something, there's a ventral stream that allows me to identify what it is. Is it threatening? Is it not threatening, right? But then the other stream is like, okay, well, where is it in space? How do I move in relation to it, right? If it is threatening, do I run away? Do I approach it if it's something rewarding, right? That those kind of elements are tied into the way that we're processing music as well, that we're understanding, and even just language in general, general too. A lot of what I was hearing from you as well is just like, okay, are they speaking really angrily? Is it something? Is the music something I want to approach? Are these people that I want to be around? Right? Is this something that I want to move to? Right? All of this is tied up to this ability to link it to how I'm interacting in the world. And something we didn't bring up when we were talking about kind of these healing aspects of music is a lot of the stuff that's going on with Parkinson's disease, which is really, really interesting. That could be kind of tied into these streams that you're talking about as well, because they're showing, like, if you show a video of someone with like kind of late stage Parkinson's disease where they've lost a lot of dopaminergic tone in their basal ganglia, which means that they've lost a lot of the dopamine neurons that are involved in moving, right? You see these people like shuffling, like they can barely lift their feet. It takes them a really long time to get across the room. But then they do music therapy with these people with these kind of rhythm heavy music and beat and everything, and you see these people all of a sudden they have what looks like a more normal gait. It's kind of in sync with the beat and all of these things, that somehow the music is allowing for a bypass around what is usually involved. The basal ganglia is usually what's involved in initiating and kind of moving us through the world. Now you have all of these other systems that are now in training to the beat, that are kind of reinstantiating, like Andrew said, this procedural memory, that are allowing the body to move in a more natural way that doesn't involve the same circuitry that it did before, which is fascinating. Again,
Yeah.
like the
No,
healing aspects
that's
of
such a
music.
good point.
Yeah, go for it.
Yeah, that's great. No, sorry, I was there's a lag there. I didn't mean to cut you off, but no, it is fascinating to see that, and it's inspiring, and it kind of it makes sense. Like music is like we were talking about before. It's a stimulus, right? It's this device, this thing, this collection of sounds that we can use to stimulate the brain in a really widespread way that is really different from other forms of even sound. It's just basic tones and stuff. It doesn't have this same integration with all these areas of the brain. And I don't know, I mean, this is pure speculation, but when you look at some of the like more technologically advanced therapies for Parkinson's disease, it tends to be a sort of like brain pacemaker that is interacting with some area of the basal ganglia, maybe the nigrostriatal pathway, and stimulating it to sort of correct for the problems that are caused by the death of those dopaminergic neurons. And maybe, again, pure speculation, music is having some sort of effect, via its ability to stimulate those structures, the basal ganglia, in addition to what Taylor was just saying, sort of bringing, maybe perhaps reawakening these procedural memories.
And like we're kind of getting to the end of the episode. I think some of the things that I really want to highlight are, first of all, this seems to be something that is somewhat uniquely human, right? There other vocal learners like songbirds and things like that have similar abilities, but it's actually really sporadic. So like if you look at Snowball the bird that I mentioned earlier, they can do this kind of dancing to the rhythm, but it's in these really short bursts. But we've evolved this ability to kind of sustain it, to have these long songs, to synchronize with others. And I think that really kind of the social aspects of this, how it's tied to who we are and how we fit in, I think is really important to kind of end on and think about, because we're showing now with like these newer studies that when you play music with people, when you listen to music with people, your brains are actually getting in sync with one another. A lot of times when you're playing music, they're getting in sync with whoever's leading the music. So if you have like a lead guitar and you have these other people that are kind of supporting him, then you show that they're actually getting in sync with the lead, and all of these things. And it shows that there's something, I think, kind of important about connecting with other people in that way, in like not just back and forth communication, right? Because that's something that we mentioned earlier, is that if I'm talking, it's this broken quality. I talk, you talk, right? But music is this way that we can kind of get on the same wavelength. We can share something and be together in something that I think is really healing.
Yeah, and to just add to your point there, like we've talked about how when you're in like a deep conversation with somebody, and far more about this because it's actually your area of expertise or part of it, that our brains tend to show more similar patterns of activity, that we do seem to see this neural synchronization, but that's only between two people, right? And one fascinating thing about music is you could have a crowd of, you know, 100, maybe not 100, 10,000 people all listening to the same song and having a really similar like neural and motor synchronization that just doesn't seem to happen with basically anything else. Maybe sports, you know, people do the wave and stuff, but it's hard to think of anything else that's quite like it.
There was this scene from that movie I mentioned earlier, Alive Inside, of this man that goes to an African village that has just been traumatized. They were attacked. These women had just brutal things happen to them, and he comes in and he starts with a really kind of traditional, really sad African song, and you see that like these women they start crying like and then all of a sudden he plays a well-known happy song right after that, and you see this whole crowd of like dozens of women that all of a sudden start moving and start smiling and start kind of coming up together. And then you see this whole crowd all of a sudden. He talks about how that one happy song then turned into over an hour and a half of them just kind of jamming out and just being together and feeling this, like you mentioned earlier, this catharsis around these moments, that all of a sudden I now feel like I'm one with these other people. I feel like I have some shared trauma, some shared history with these people that now we can work through together. We can see together, and I think that's something to me that has stood out the most in this research, is that while it's really fascinating and amazing how music perception works and how it's connected to all of these systems, can reignite memory and all of this, the healing aspects have just stood out to me as just being just mind blowing. And the fact that we don't have it as just a traditional form of medicine that's covered by insurance or whatever. There's no medication on the market that can wake someone up, that can give someone a feeling of joy the way that a good piece of self-connecting music can for somebody.
That's really amazing. And I feel like there's so many more aspects of music that we could have touched on this episode, and maybe we'll save that for a future episode or for the Patreon only episode, actually, which we will have coming out probably later this month or next month. But we'll kind of bring together what we talked about in our last episode on time and timing in the brain and music and music perception, and kind of maybe talk about some of the things we didn't mention here, like creativity and improvisation and some of these really fascinating things that people are able to do with music. So if you want to see that, go to our Patreon, go to patreon.com/thesocialbrain, and there'll be a link in the description of this video, and check it out. Decide, if you want to support us. We really appreciate it. We love doing this, but it also, will help us keep the lights on if you want to support us. And we really appreciate just your viewing of it, but also consider joining the Patreon.
And to all of you that have kind of been with us for as long as you have and continue to tune in, thank you for your support. We love doing this. This is episode 41. I don't know how that happened. And we just did a whole episode on time. That time disappeared, right? But thank you. This is really kind of a remarkable thing that we've put together, and it's really fun to do.
Yeah. All right, guys. Well, thank you. We'll see you next time.